day, viewers. Welcome to the Physics Mind. Today, we will look at some technical questions on friction. And in our previous video, we have explained the basic concepts on the coefficient of friction and then some simple illustrations on how we can calculate the coefficient of friction. Now, today we have a technical question before us, and let's look at the question and see how we can solve it. Okay, so the question we have is, we have a diagram and we are told that this diagram illustrates a block of weight W just on the point of sliding down a rough inclined plane at an angle to the horizontal. Okay, so this is an inclined plane and then at a particular angle to the horizontal. So this is the angle of inclination theta from the diagram. So this is a block of wood and then this is a force tending to pull the block up, and then the weight of the block is acting downward. So we are asked to firstly derive the expression for the coefficient of static friction between the block and the plane. And then when we are done with that, we are told if the mass of the block is 5 kg and the angle of inclination is 30 degrees, calculate the normal reaction of the plane on the block. And lastly, we are told to find the force that overcome the frictional or the static friction of the block. And we are given G to be 10 meters per second square. Okay, so the first thing for us to do is we need to what? To redraw this diagram and indicate all the forces that are acting on this block of wood on this inclined plane. Okay, so I'm going to redraw the diagram. This is my inclined plane, inclined at an angle theta to the horizontal. So this is the block of wood, and the weight of the block is acting downward. And we are told that there is a force that is pulling it up. Okay, so one thing we need to know about a body resting on an inclined plane is that the weight of the body has two components. The weight of the body has two components, which is the horizontal component and the vertical component. So that is, we are saying that this weight has two components from vectors. So we are going to resolve it into the horizontal and the vertical component. All right, so the weight, this is one of the components, and this is the horizontal component. So let's call it the W cos theta, and this is the vertical component. This is considered to be the vertical component and is going to be W sine theta from vectors. Remember, from a vector, if you want to resolve a vector that is inclined at an angle to the horizontal, then the horizontal component of that vector will be the magnitude of the vector multiplying by cosine of the angle, while the vertical component will be the magnitude of the vector multiplied by sine of the angle. So in this case, we consider this to be the horizontal component and this to be the vertical component. So the weight is inclined at an angle also theta to the horizontal, since we consider this to be our horizontal. Remember that this angle here is the same as this angle. And also, you need to know that what, since the block is resting on the inclined plane, and of course, the plane is also going to react back on the what? In the block of wood, according to Newton's third law of motion. To every action, there must be an equal what? Opposite what? Reaction. So the reactional force is going to be acting what? Upward. So this is the reactional force of the plane back on the what? The wood. So by this we have a comprehensive diagram of the what? All the forces that are acting on the block of wood. So we can go ahead to find what we are expected to find. We are asked to first of all derive the expression for the coefficient of static friction between the block and the plane. So we are asked to derive an expression. So how do we derive the expression for the coefficient of friction? Now, remember that the coefficient of friction, mu, is equal to frictional force over the normal reaction. Frictional force divided by the normal reaction. But then, for a body resting on the inclined plane, we need to know that we are told that the body is just at the point of sliding down. Just at the point of sliding down. So at that point, we can consider that what? The body is at equilibrium or it is at rest. So if the body is at equilibrium or it's at rest, it means that the force that is tending to pull it upward is equal to what? The force that is tending to also what? Pull it what? Downward. And similarly, we can also say that what? The normal reaction which is acting upward is equal to the what? The horizontal component of the what? The weight of the body. So we can say that at equilibrium, the frictional force or the force tending to pull it up is equal to the vertical component of the weight, which is equal to W sine theta. And similarly, normal reaction is equal to the what? The horizontal component of the weight, which is W cos theta. Now remember that this is only true if the body is just at the point of sliding down or the body is at equilibrium. But if the body is actually moving or sliding on this inclined plane, then this statement is not what? True. So we are only taking this statement because we are told the body is just at the point of sliding down the plane. So if it's at the point of sliding down the plane, then it means that this force in this direction must be equal to the force in this direction, and this force in this direction must be equal to what? The force in this direction. So we will substitute in order to derive the equation for our coefficient of friction. So our coefficient of friction, mu, can now be our frictional force, which is equal to W sine theta over the normal reaction, which is W cos theta. So if W goes with W, so we have mu to be equal to sine theta over cos theta. But remember from trigonometry that sine theta over cos theta is equal to tan theta. So if that is so, then we can say that the coefficient of friction is equal to tan theta. So this gives us the what? The expression or the equation for the coefficient of friction for a body that is what? Sliding down an inclined plane. All right, so we have explained, obtained the expression. So the second part of the question says, if the mass of the block is 5 kg and the angle of inclination is 30 degrees, calculate the normal reaction of the plane on the wood. So we are told that, second part, we are told that if the mass of the block, that is mass, is 5 kg and the angle of inclination, theta, that is this angle here, is what? 30 degrees. So we can write theta is 30 degrees. We should calculate the normal reaction of the plane on the block. So we are looking for normal reaction R. Okay, so we're looking for the normal reaction. One thing you need to know is that for a body resting on the inclined plane, the normal reaction is not equal to the weight, but is equal to the horizontal component of the weight. So it is not a horizontal surface. It is only in a horizontal surface that the normal reaction will be equal to what? The weight. But for a body resting on an inclined plane, the normal reaction is equal to the horizontal component of the weight, not the weight itself. So since we are looking for the normal reaction, so we can say that our normal reaction is equal to the what? The horizontal component of the weight, since the body is just at the point of sliding down. So our normal reaction, which we know is equal to W cos theta. Okay, so But then W we know is the weight of the body, and the weight of the body is equal to the product of the mass multiplied by gravity. So normal reaction, we can write it as mass multiplied by gravity and then cos theta. Okay, so our normal reaction becomes the mass of the body in kg, which is 5, times g is acceleration due to gravity, and we are given from the question to be 10 meter per second square. So we have times 10 times cos theta, which is the angle of inclination, which is 30. So our normal reaction becomes 5 times 10, which is 50, and then cos 30. So our normal reaction, so 50 times cos 30, we are going to be pressing my calculator. So 50 times cos 30, so that is equal to 43.30. That is 43.30 Newton. So that gives us the normal reaction of the plane on the wood. So the last part of the question says we should find the force that overcome the static friction of the block. We should find the force that overcome the static friction of the block. So that force must be equal to the what? The vertical component of the weight. So that means this is the force, and then this is the what? The vertical component of the weight. So for us to do that, let's. Okay, so we are looking for the third part of the question. So the force, and we say that that force must be equal to W sine theta. That means that that force must be equal to what? The vertical component of the weight. Remember that you can also use your force to be equal to what? Mu r. That means you find your coefficient of friction, which is equal to tangent of the angle, and the angle is 30. So you can find your tan 30 and multiply it by your normal reaction. You have your answer. Or you can multiply the weight by sine of the angle. You have your answer. Okay, so we have our force to be equal to the weight of the body. We know is mass multiplied by gravity and then sine theta. Okay, so our force now becomes mass of the body is 5 kg times gravity, which is 10, times sine of the angle, which is 30. So our force now becomes 5 times 10, which is 50, and then sine 30. So our force becomes 50 times sine 30, that is 0.5. So our force becomes 50 times 0.5, that will give us 25 Newton. Okay, so this gives us the force that is required to overcome the static friction. All right, thanks for watching. Make sure you like and subscribe to my channel.